Have you ever wondered how your favorite apps just work? How they get all their information from the internet? Well, they use something called an API. Today, we're going to pull back the curtain and build one from scratch using Spring Boot. We'll break it all down into simple, clear steps so you can get started building your own. Let's dive in. So really, how do all these different apps and websites talk to each other and to the internet? The answer, like we said, is an API, an application programming interface. You can think of it as a universal translator for the web. And the best part? Tools like Spring Boot make building them way easier than you might think. So here's our game plan for today. We're going to start with the absolute basics, the blueprint. What is a REST controller? Then we'll lay our very first brick by creating a simple API endpoint. After that, we'll build out the core functions, figure out how to pass data right in the URL, and finally, add that professional polish by handling errors gracefully. Okay, first things first. Before we can build anything, we need to understand the blueprint. We're building what's called a REST API, and the absolute heart of it all in Spring Boot is a little something called a controller.
Think of REST like a language. And every language has verbs, right? Action words. Well, in the world of APIs, those verbs are the standard HTTP methods you see here. Get is for fetching information. Post is for creating something new. Put is for updating what's already there. And delete, well, that one's pretty obvious. These four actions are the foundation of basically everything you do online.
So the controller is the brain of our operation. It's kind of like a traffic cop for our API. It stands there, listens for all the incoming requests from the outside world, looks at what they want to do, like a get or a post, and then directs traffic and sends back the perfect response.
Now, check this out. This little line of code at REST controller is our first magical Lego block. It's an annotation in Spring that does so much heavy lifting for us. You just pop it on top of a class, and you're telling Spring, hey, this class right here, it's an API controller. And even better, it automatically handles turning our data into JSON, which is the language that all browsers and other apps can understand perfectly.
All right, that's enough theory. Let's get our hands dirty and actually see this thing in action. We're going to build our very first, super simple Hello World endpoint. This is where it all starts to click.
It's really just a three-step dance. First, we use that @REST controller annotation we just talked about. Second, we create a simple method and tell it which URL to listen to with @getMapping/hello. This is basically saying when a GET request comes to the /hello address, run this method. And third, the method itself just returns a simple piece of text. That's it. So, once our application is running, all we have to do is open up a web browser and punch in this address, our local server, followed by /hello. This simple action sends that GET request right to the endpoint we just built. And boom, just like that, the API sends a response right back. The string that we returned in our code pops up in the browser. And with that, we've laid our first brick. We have a real, working API endpoint. It's that easy to get started. That was a great start, but let's be real. Most applications do a bit more than just say hello. So now we're going to expand our API to handle the 4 fundamental operations you'll find in pretty much any modern app.
These operations are often called CRUD. It stands for create, read, update, and delete. And what's awesome is that Spring Boot gives us a clean, dedicated annotation for each one. It makes the code so easy to read. You want to read data? Use @getMapping. You want to create new data? @postmapping. It's incredibly intuitive.
Now, when we're creating or updating something, that new data has to come from somewhere, right? It comes in with the user's request. And that's where @requestBody is essential. It tells our method, hey, expect some JSON data to come with this request, and please turn it into a Java object I can actually work with. It's the main doorway for information coming into our API.
So far, our URLs have been pretty static, just /hello. But what if we want to get information about one specific student or search for a student by their name? For that, we need our URLs to be dynamic, and Spring gives us 2 fantastic tools to do just that.
This slide lays it out perfectly. On the left, we have @pathVariable. This is for when the data is a core part of the URL path itself, like an ID. For example, /student/5 is clearly asking for the student with ID number 5. On the right, you've got @requestVariable. This is for those optional bits that come after a question mark, which are perfect for things like filtering or searching. Knowing when to use which is a real game changer.
Okay, our API is getting pretty powerful now. But what happens when something goes wrong? A user sends some bad data or tries to do something impossible. Well, how we handle those errors is what separates a hobby project from a truly professional and robust application.
So, let's create a problem on purpose. Imagine we have an endpoint that divides two numbers. What happens if some clever user sends a request trying to divide by 0? We all remember from math class, you just can't do that.
Well, without any special handling, the server would basically have a meltdown. It would crash that request and spit back a long, ugly, and totally unhelpful error message. This is a terrible experience for the user and tells them absolutely nothing useful. We can do so much better.
The solution is another one of these amazing annotations, @exception_handler. You can think of it like an emergency response system for our API. We create a method, put this annotation on it, and tell it exactly which error to watch for. When that specific error happens anywhere in our controller, this method swoops in, catches it, and lets us send back a clean, custom, and helpful response instead.
And this is the beautiful result. Instead of a scary wall of red text, the user gets a simple, clean message that actually explains what went wrong. Now that is professional, it's user-friendly, and it makes our API feel way more reliable.
So let's quickly recap our new API toolkit. We've got @REST-controller as the foundation of the whole thing. We have our action verbs like @get mapping and @post mapping. We have @pass variable and @request variable to make our URLs dynamic, @request body to let data in, and @exception handler as our critical safety net. These really are the core building blocks you'll use again and again.
And there you have it. We've gone from a simple question to a functional, robust API blueprint. You now have the fundamental tools, the Lego blocks, to make all kinds of applications talk to each other. So the only real question left is, what are you going to build first?